Do you remember tangent x? You could write tangent x in the form of sine and cosine. Yes, Benjamin, what did you say?
Sine over cosine.
Yes, tangent x is sine over cosine x dx. Now it's better because we have two functions, sine and cosine. Maybe I could use now integration by substitution method. What should I do here?
Pick sine as u because the derivative of sine is cosine, while the derivative of cosine is minus sine.
Yes, wonderful, Simeon. So there is a cosine x and sine x, and they are connected to each other somehow. I mean, the derivative of sine x is cosine x, the derivative of cosine x is minus sine x, so they are connected to each other. So we may pick u here. What we are gonna do is choosing u, selecting u, and you said u is cosine x. So wonderful. Let us try. If u is cosine x, what will happen? So I will write it here. U is cosine x. I need to take the derivative of both sides. Du over dx will be equal to minus sine x. So here, let me replace cosine x. We said that that's u. Here you will have sine x times dx.
Sir, why we didn't choose sine x? I couldn't catch it.
Really good question, Ahmed. If you choose u sine x, let me write that option here. I will write it here. If u is sine x, you will get this. Du over dx is cosine x dx. This is the first option. The second option is, let me write the second option here. We said that u is sine x, dx is here, and cosine x is there. We have two different options. In the first option, you need to replace sine x times dx. In the second option, you need to replace dx over cosine x. Look at the first option. Sine x times dx. Do you see sine x times dx here? I mean, here, du over dx is minus sine x. Yes. When you multiply these two, du will be equal to minus sine x times dx. I need only this part. Minus du is sine x times dx. Then my integral becomes 1 over u times minus du. I will put the negative sign in front of the integral. 1 over u du. Do you know the integral of 1 over u? We know how to do that. 1 over u is a famous integral. What was the integral of 1 over u? 1 over x or 1 over u? It is here we have
something ln x or something.
ln absolute value of u plus c. That's the integral. Then translate u back to x. It becomes negative ln cosine x is u, cosine x c. We got the integral. If you look at the calculus books, integral of tangent x will be negative ln absolute value of cosine x plus c. What about our second option, Ahmed? Now look at this. You need to find dx over cosine x. But what you have, here I wrote times dx. We have only cosine x here. So when you multiply these two, you will get du is equal to cosine x times dx. But you need du over cosine x. How can I get du over dx over cosine x? I cannot get dx over cosine x here. I have a product. I don't have the ratio of them. So it doesn't help us. I cannot continue anymore. There is no next step. Because dx over cosine x, I cannot replace dx over cosine x here. I cannot write it in terms of u. But in the previous option, first option, sin x times dx is negative du. So u should be cosine x, not sin x. And there is one more thing. In the previous option, we may go one step further. If we apply the properties of logarithmic function, you could take this negative sign here. It becomes ln absolute value of cosine x negative 1 plus c. So that negative 1 means absolute value of 1 over cosine x plus c, and the final result will be ln secant x plus c. So the integral of a tangent function will be this.